7, more with rational functions and some application problems with some basic polynomial types. Right, so we're going to do more with rationals than we are actually going to do more with polynomials. So we've graphed and talked about the different aspects of rational functions. So the next step of the process is to solve equations with rational functions. That's what we're going to do. We're going to solve them both algebraically by hand, and then I'm going to show you how to solve them graphically. We are going to solve inequalities, greater than, or equal to, both polynomial types and rational types, and we'll do them both mostly on graphically, because those are easier to solve graphically. Right? And then we're going to do some application problems involving variations, so some more applications. Alright, rational equations. So these are whenever we have a function that involves a rational expression and equality, right? Equal sign. Alright, so rational expressions. Rational expressions can always be written as, and this is what we'll usually do, some rational polynomial divided by another polynomial set equal to some constant. Right? So we've got a couple of examples here. There's actually two separate that just got smushed together. There's one example, and there's my second example. So the first one is just a single rational function set equal to the constant 0. The second one, there's two rational functions. There's the 2 divided by x minus 1, and then the rational expression 1 divided by x is equal to a constant. And those are the types of equations we're going to solve. So the first step we're going to solve is we're going to solve them what the book calls symbolically or algebraically by hand. And so the steps to do that is the easiest way is set the equation equal to the constant. So move your rationals to one side, your constant to the other side, or whatever that constant is. Then you're going to multiply by the lowest common denominator, the LCD. And what it really comes down to is usually just multiply by whatever all of the denominators are. Right? Because that clears the fractions, right? It gets rid of the fractions. And once you clear the fractions, what you should be left with is a polynomial equation, which we practice solving polynomial equations in the first half of Chapter 4. The biggest thing about these is because we started out with a rational expression, you always have to double check your answer. There are some answers that we get that aren't in my domain, and we throw them out. They're called extraneous solutions. We got an answer to the polynomial part, but it wasn't a part of the original rational part. Okay? So you always have to check that we do not get division by 0. And then sometimes we have to throw them all out, and the answer is no solution. And there's no solution possible because all the solutions that I got are either not real or cause division by 0, which I can't do. Alright, so the first example, which apparently didn't make it very big. 4x over x minus 1 equals 6. So actually it's already set up for me. Set where I've got my rational on one side, my constant on the other side. And so the denominator is x minus 1. And that's it. That's the only denominator, so that's the lowest common denominator. So basically I'm going to get rid of the division by multiplying both sides by that denominator. So I'm going to multiply this side by x minus 1. Well, ever do one side of my equation, I have to do the other. These two things reduce to 1. They cancel each other out, and so I'm left with 4x on that side. 6 times x minus 1, so I'm going to go ahead and distribute my 6. So 6x minus 6, and there's my polynomial, which I can solve that pretty easily. So I'm going to move the 6x to the other side. So I'm going to get negative 2x equals negative 6 divided by my negative 2. And so I get the solution, x equals 3. And then I always have to check to make sure that I didn't get any division by 0. So we go check, and I plug it into my original function, and it checks. The only number I can't plug in is 1. 3 works, right? So I get 3 minus 1, which is 2, and that's perfectly fine. So this is my solution. Checks. All right, next example. Now, again, my rule of thumb is always move all of all of the rational parts to one side, the constants to the other. Now, you don't have to do that. That's just my rule of thumb. So I like to put all my rationals to one side. So I'm going to move the 1 over x to the other side. So I have 1 over x squared plus 1 over x equals 2, right? I just added the 1 over x to move it to the other side. And then there's a couple of different ways you can solve it. You could combine the fractions, or you could clear the fractions. And again, it's up to you. There's more than one way you could do this. I'm going to clear the fraction. The lowest common denominator, I've got an x and an x squared. Remember, x squared just means 2 x's, right? X times x. So if I multiply by 2 x's, by x squared, I should be able to get rid of all my division parts. And so that's what I'm going to do. I'm going to multiply this side by x squared. That's the lowest common denominator. Whatever I do to one side, I have to do to the other. And so remember, I multiply the whole thing. So over here, it's going to be x squared divided by x squared divided by x, and then here I still have the 2x squared. And I wrote it out. Now this, if you wanted to do this middle step as a mental step, you can. That's what you're doing, right? I multiply by my x squared, both parts. And then I simplify. X squared divided by x squared simplifies to 1. X squared divided by x simplifies to x, right? 1x cancels with one of those and leaves me with x. And then over here I still have a 2x squared. Now I have a polynomial. I have a quadratic. I know how to solve quadratics. Right, to solve quadratics, I set it equal to 0. And so I'm going to move the 1 and the x to the other side. And when I do, I'm going to reorder it. So over here I'm left with 0, right? Those 0 out, leave me with 0. And then I've got 2x squared minus x minus 1 once I've moved them over. And now I factor. Or again, you can solve, we practice solving quadratics in chapter 3. So there's a bunch of ways you can solve it. You can graph it, find its zeros. You can use the quadratic equation. Or you could factor. And I'm going to factor. Right, this factors into 2x and x, right? The only way to split 2 is in 2 and 1. The only way to split negative 1 is 1 and negative 1. And then I just have to make sure I put the 1 and the negative 1 in the right spot. So if I put negative 1 here, positive 1 there, there's my guess. And then I check. Multiply it out, I get 1, negative 2. 1 and negative 2 gives me negative 1, and so it checks. And so I have a solution negative 1/2 and positive 1. Right, because I set each of those to 0. And so one solution is negative 1/2 and positive 1. And then you check them. I'll go back to the original to check. The only number I can't have is 0, right? So both of them check. I'm good. I don't have to worry about it. They both check. So there's both of those are my solutions. Alright, next example. And so when I'm solving this, now this one I'm probably just going to leave the way it is because they're both fractions on either side. And actually this is a proportion. Proportion means there's one fraction on one side set equal to another fraction, and that's it. There's nothing else but the two fractions set equal to each other. And when I have a proportion, what I can do to solve it is I can cross multiply. I can only cross multiply if I have this type of expression, a fraction equal to another fraction. And then when I do, I cross, and so I'm going to get 4 times the x minus 1 equals 3 times the x minus 2, and then I'm going to simplify that. So distribute the 4 here, 4x minus 4, distribute the 3 there, 3x minus 6, and there's my polynomial that I can solve. So I'm going to move the 3x over, so I get x minus 4 equals negative 6, move the 4 over, I get x equals negative 2, and then check, and this one I really do need to check, but I'm okay because it's a negative 2. Right, negative 2 minus 2 gives me negative 4, it's fine, and same thing over here, that would give me a negative 3, so it checks. Alright, next example. Alright, so this is the last example I'm going to do by hand, and then we'll get to the graphing method, and we'll do that in the next video. So first thing I'm going to do is move the 3 over, and so I get 2 over 2x plus 5 equals negative 4. And if I wanted to, I could treat this like the last example. I'm going to get rid of the divide by x, 2x minus 2x plus 5, by multiplying both sides. This is like the first example. Multiply both sides by that 2x plus 5. Those reduce, leave me with 2 on that side. I've got the negative 4, I've got to distribute. So I get negative 8x minus 20. So move the 20 over. So 22 equals negative 8x. Divide by my negative 8. And so x equals 22 over negative 8. Always write it reduced form. I can reduce that to negative 11 over 4. And it checks. If you plug in negative 11 over 4, there's no problem. I didn't do any with any errors. But if you've got an answer that doesn't check, so if I had gotten, in this case, -5/2, that would have given me an error. I would divide by 0 and I'd throw it away. Alright, so again, if I check it, so I do a quick check. Does it work? Yeah, it does. You should always do that. And if ever you run into a case where it doesn't work, you throw that out. Alright, you don't want that solution. So that finishes up by hand. And then I'm going to show you how to do it on the calculator. So you can either solve it by hand or you can solve it graphically. And so the next example is solving it graphically. So I'm going to do that in the next